Hello, welcome to today's lesson on sections 4.5 and 4.6. The plan for today is to cover all 4.5 and do a little bit of 4.6 just so we get caught up here. Um, section 4.5 is titled the following: Solve quadratic equations by finding square roots. Now, earlier today, and today is Monday, so you might be watching this on Tuesday if you're a G period student, we did some examples like these. Simplify. Say you're asked to simplify that root 80. You may have done this in middle school. It's pretty simple. What you want to do is you want to break down into its prime factors. So you do a little prime factor tree. So again, break down into prime factors. And what you want to do is pull these out in pairs. So let's say we have a pair of 2's here. And we have another pair of 2's. So root 80 is the same thing as saying the square root of 2 to the 4th power times 5. Or you could break it apart like this. 2 to the 4th power is 16, which is just going to be 4. So you just get 4 root 5. Let's try another one. Say you're asked to simplify root 6 times root 21. So you can multiply the two numbers together to get 126. Break it down. That'll be, 6 and 21. That's what we got from earlier. 2 and 3. 3 and 7. Quick and easy way is look for pairs. So in this case, root 126 will be 3 root 14. Basically what I do is anything that pairs up goes on the outside. Anything that's single stays inside, and 2 times 7 is 14. So if that makes some sense. Here's another type of problem. So we have root 5 over 2. You're asked to simplify that. We can simplify both top and bottom separately. But then, what you want to do is something like this here. This process is called Rationalize the Denominator. And since what you're doing is that root 2 is not rational, and of course that's in the denominator, right? But root 2 times root 2 is, because that's going to be root 4 or 2. So that's what's meant by rationalize the denominator, is just multiplying both top and bottom by the denominator. 4 is going to be a little bit different though. In this case, what you do is you multiply both top and bottom by 7 minus root 2. This is called the conjugate of 7 plus root 2. When you work it out, you get 21 minus 3 root 2 over 7 times 7, which is 49, minus 7 root 2 plus 7 root 2 minus 2. So essentially what we're doing is we're foiling 7 plus root 2 is 7 minus root 2. Continue working it out, and the bottom will be 47. So we did some of this in class, but I just kind of wanted to repeat that. Fifth example, let's say you're asked to solve, because the course is about solving equations. Say you're asked to solve the following. 1/2, actually I take it back, 1/5 x plus 3 squared equals 7. What you want to do is isolate x plus 3 squared, which would be 35, because I multiply both left and right by 5, so that these cancel. Then square root both sides. So instead of foiling, you can just square root both sides. And the beauty about that is that square over square root goes away, so you just get x plus 3, because they're inverses of each other. However, you do have to say plus or minus. And the reason why you have to say plus or minus, because x plus 3 could be positive or negative. Because when you square a positive is positive, square a negative, it also comes out as being positive. So it could actually hold two values. So x equals -3 plus or minus root 35. You could have foiled x plus 3 squared and then use quadratic formula, which we're actually going to do, I think in 4.7. No, take it back. I think 4.8, yeah. But this is actually a more efficient way. Here's another example, a little simpler. Probably should have started with that one. That's right. So you have to solve 3x squared plus 5 equals 41. So 3x squared will equal 36. X squared equals 12. X equal plus or minus root 12, which is plus or minus 2 root 3 when you simplify it. Again, you need the plus or minus, since negative root 12 squared equals 12, and root 12 squared equals 12. And also, notice how we isolated the squared term. And then you can just take the square root. Hence, the name of the section. Solve quadratic equations by finding square roots. I'm now going to start talking about 4.6, but let me add a 7th example here. And here's the 7th example. It's going to be 2x squared minus 5 equals, let me think about this one here. I don't know why I'm drawing a blank. I think negative 41. Yeah. I'm going to stop the video right now and make a part 2 because I don't want this to run over 15 minutes. So watch part 2 to see me work out number 7.